Today we'll discuss ISI's B-Stat and B-Math 2012 paper, and this paper again had some wonderful questions. And the first question is, a rod AB of length 3 rests on a wall as follows. P is a point on AB such that AP upon PB is 1:2. If the rod slides along the wall, then locus of P lies on. Now suppose this angle is theta. Then coordinate of B, it will be 3 cos theta comma 0, and coordinate of A will be 0 comma 3 sin theta. Now P, it divides it in the ratio 1:2. Now we need to find locus of P. Now first step, identify the point. It is this point P. Let it be alpha comma beta. Now we'll use section formula. We can write alpha as 3 cos theta upon 3, and we'll write beta as 2 into 3 sin theta upon 3. This 3 and 3 will cancel. Now we have to eliminate this parameter, which is theta. Cos square theta plus sin square theta is 1. So we'll write alpha square plus beta square by 4. It is equal to 1. And in the end, we'll change alpha with x and beta with y. So this required locus will be 4x square plus y square, and it is equal to 4. And that's your option B. Now the next question is, consider the equation x square plus y square equals 2007. How many solutions x, y exist such that x and y are positive integers? So what we are given is, we are given x square plus y square equals 2007. Now this right hand side, it is an odd number. So this number will be odd if one of x and y, it is odd and the other one is even. Now suppose we take x as an odd number and y as an even number. So let it be 2n square and let y be 2m plus 1 square, and it is equal to 2007. We can write 4n square plus 4m square plus 4m plus 1, and it is equal to 2007. Now this is 4 n square plus m square plus m, and it is equal to 2006. Now we can write this as 4 into 501 plus 2. Now this left hand side, it is a multiple of 4, and right hand side, it leaves the remainder 2 when divided by 4. So 4 modulo left hand side is 0 and 4 modulo right hand side is 2. So left hand side can never be equal to right hand side. So this equation has no solution, and that's your option A. Now here the question is, consider the function f1x equals x and f2x equals 2 plus log x, where x is greater than 0. The graph of the function intersect in which of the following intervals? Now what we'll do is, we'll define a function, say fx, which is x minus 2 plus log x. Now we find f dash x will be 1 minus 1 upon x. So this is x minus 1 upon x. So we are given that x is greater than 0. So the only critical point here is 1. Rightmost is plus and this is minus. So there is a local minima at 1, and the value of this function at 1 will be 1 minus 2 plus log 1 is 0, and will be minus 1. Now if we take f0 positive will be 0 and then minus log 0, which is plus infinite. So this function, it starts from infinite at 1. It takes the value minus 1, and then at infinite, it'll again take the value infinite. So the graph of this function, it will be something like this, where this is 1 and the value at 1 is minus 1. So this equation has one root between 0 and 1. That means these two graphs, they'll intersect once in 0, 1 And then we have to find this other option. Now, if we find FE, now FE is E minus 2 plus log E. It is 1 and it is less than 0. And if we find FE square, it will be E square and then minus 2 plus 2, which is greater than 0. So E will lie here and E square will lie here. So this other root, it will lie between E and E square. So these two graphs, they'll intersect once in 0, 1 and once in E, E square, and that's your option C. Now question number 4 is, we need to find this limit un as n tends to infinite. Now this un is nothing but AGP. So we can write this limit of un as n tends to infinite as some value, say s. Now s is equal to 1 upon 2 plus 2 upon 2 square, 3 upon 2 cube, and this sequence will continue up to infinite. Now we'll again write the sequence by shifting one term and we'll multiply it with 1 by 2. So here it will be 1 upon 2 square, here will be 2 upon 2 cube up to infinite. Now we subtract second sequence from first, we'll write s by 2 and it will be 1 by 2 plus 1 by 2 square plus 1 by 2 cube up to infinite. So it will be s by 2 and this is nothing but infinite GP, which is a upon 1 minus r, that is 1. So value of s is simply 2. So this limit n tends to infinite un, it is nothing but 2, and that's your option B. Now here the question is, suppose z is any complex number which is not equal to 3 omega and 3 omega square, where omega is complex cube root of unity, then we need to simplify this expression. Now we can write this as z minus 3 omega into z minus 3 omega square plus z minus 3 into z minus 3 omega square plus z minus 3 into z minus 3 omega upon z minus 3, z minus 3 omega and z minus 3 omega square. Now we'll multiply them. We can write z square minus 3z omega plus omega square and then plus 9 omega cube, which is 1. Now here we'll take z minus 3 common, then it'll be 2z and then minus 3 omega plus omega square. In the denominator, it'll be z minus 3 and then z square minus 3z omega plus omega square and then plus 9. Now this is z square. Now omega plus omega square is minus 1. So it will be z square plus 3z plus 9. And here will be z minus 3, 2z. Now again omega plus omega square is minus 1. So it will be 2z plus 3 upon z minus 3, z square plus 3z plus 9. So it will be z square plus 3z plus 9 plus 2z square plus 3z minus 6z minus 9, and this is a minus b into a square plus b square plus ab. So it will be a cube minus b cube. So it will be simply z cube minus 27. Now 6z and minus 6z will cancel. 9 and 9 will also cancel. So it will simplify to 3z square upon z cube minus 27, and that's your option D. Now question number 6 is, consider all functions defined from 1, 2, 3, 4 to 1, 2, 3, 4, which are 1, 1 on to n, satisfy the following property. If fk is odd, then fk plus 1 is even. Now we are given that we have this function f, which is defined from 1, 2, 3, 4 to 1, 2, 3, 4, and it will be a bijective function with the given property. If fk is odd, then fk plus 1 is even. Now we have 4 elements in domain set, and they are 1, 2, 3, and 4. Now what are the possibilities? Now one possibility is when this 1 is odd. If 1 is odd, then this 2, it must be even. Now this 3, it can be odd. Then this 4th, it will be simply even. So this is one possibility. Another possibility is this 1 is odd, then 2 is even, 3 is even, and 4 is odd. And we'll have one more possibility, which is when we have 1, 2, 3, 4, where 1 is even, 2 is odd. If 2 is odd, 3 is even, and then this 4, it will be simply odd. Now in the first case, for this one, we have to choose an odd image, and we have 2 options. So number of options here will be 2. Now again for 2, we have to choose even number, again 2 options. Now for 3, there is only one number left because the function is bijective, 1, 1 and on 2. Again for this is 1. So total number of such functions will be simply 4. Again for the second one, 2 choices here, 2 choices here, 1 here and 1 here. So again we have 4 choices. Now for this one, 2, 2, 1 and 1, again we have 4 choices. So total number of such functions will be 4 plus 4 plus 4, which is 12, and that's your option C. Now question number 7 is, we are given this function and we have to find whether this function is continuous, differentiable, or f dash is continuous or discontinuous. Now if we look at f 0 negative, it is 0, f 0 is also 0, and f 0 positive, it will be e to the power minus 1 upon h. E to the power minus infinity is nothing but 0. So this function is continuous. So this function is continuous in x belongs to R. Now we'll check its differentiability. Now left hand side, it is a constant function. So f dash 0 negative, which is left hand derivative, will be nothing but 0. And what about right hand derivative? It will be f dash 0 positive, which is given by limit h tends to 0, e to the power minus 1 by h minus 0 upon h, which is 0 upon 0 form. Now we can write this as limit h tends to 0, 1 upon h upon e to the power 1 upon h, which now is infinity upon infinity form. If we use L'Hopital's rule, we can write limit h tends to 0. Now this is minus 1 upon h square will be e to the power 1 upon h into minus 1 upon h square. So we'll cancel. Now e to the power minus infinite, it is nothing but 0. So left hand derivative is 0 and right hand derivative is 0. So this function is differentiable at x equal to 0. So fx is differentiable in x belongs to R. Now we have to find whether its derivative f dash, it is continuous or discontinuous. Now if we look at f dash x will be defined as e to the power minus 1 by x into 1 by x square when x is greater than 0, and it will be 0 when x is less than 0. So f dash 0 negative, it is nothing but 0. And if we find f dash 0 positive, it will be this limit h tends to 0 e to the power minus 1 by h upon h square. Now this is nothing but 0 upon 0 form. Now again we write this as limit h tends to 0 1 upon h square e to the power 1 upon h, which is infinity upon infinity form. We can write this as limit h tends to 0 and L be minus 2 upon h cube e to the power 1 upon h and then minus 1 upon h square. This minus and minus will cancel. H square will cancel. We can write this as limit h tends to 0 2 upon h e to the power 1 by h, which again is infinity upon infinity form. So again, if we use L'Hopital's rule, we can write limit h tends to 0 minus 2 upon h square e to the power 1 by h minus 1 upon h square. So it will be 2 e to the power minus 1 by h, and e to the power minus infinity is nothing but 0. So at 0, left hand limit of f dash is 0, right hand limit is 0, and function value is also 0. So f dash is continuous at x equal to 0, and therefore f dash x is continuous everywhere. So answer to this question is f is differentiable and f dash is continuous, and that's your option D. Here the question is, find the last digit of factorial 9 plus 3 to the power 9966. Now factorial 9, we know that it has 2 into 5. So last digit in this case will be simply 0. Now what about this? Now we can write 3 to the power 9966 as 3 square to the power 4983. So it will be simply 9 to the power 4983. Now we can write this as 10 minus 1 to the power 4983. Now using this shortcut, last digit will be minus 1 to the power 4983, which is minus 1. Now since remainder cannot be negative, so we take its complement with 10. Complement of minus 1 with 10 is 9. So the last digit in this case will be simply 9. And that's your option B. Now question number 9 is, consider this function when x lies between 2 and 3. We need to find maxima or minimum of this function in this interval. Now we find f dash x will be 2x minus 1 and L be 4x plus 3 and then minus 2x square plus 3x plus 1 into 2 upon 2x minus 1 whole square. So it will be 8x square plus 2x minus 3 and then minus 4x square plus 6x plus 2 upon 2x minus 1 whole square. So it will be 4x square minus 4x minus 5 upon 2x minus 1 whole square. Now, if we add 1 and subtract 1, we can write 2x minus 1 whole square minus 6 upon 2x minus 1 whole square. Now we put it equals to 0, we'll get x as 1 plus minus under root 6 upon 2. Now 1 plus minus root 6 by 2, it doesn't lie in this interval. So that means there is no critical point in this interval 2 to 3. And this is 1 minus root 6 by 2 and this is 1 plus root 6 by 2. And here this value will be 2. In this interval, f dash x is greater than 0. So this f dash x, it is greater than 0 when x belongs to 2 to 3. That means this function fx is an increasing function in this interval. Now when the function increases, its minimum value will be at the start of this interval and its maximum value will be where this interval ends. So if we find f2, f2 will be 8 plus 6 plus 1 upon 4 minus 1 is 3. So it will be 9 plus 6, 15. 15 by 3 is 5. And its maximum value will occur at x equals 3. And it will be 9 into 2, 18. 18 plus 9, 27. 27 plus 1, 28. 28 upon 5. So maximum value of this function f is 28 by 5. And that's your option C. Now question number 10 is, a particle P moves in the plane in such a way that angle between the two tangents drawn from point P to this curve y square equals 4ax is always 90, then the locus of P is. So we have to find point of intersection of perpendicular tangents for this parabola. Now let this point be alpha, comma, beta. Now we know that for this parabola, equation of tangent is given by y equals mx plus a by m. So here it will be y equals mx plus a by m, and this tangent, it passes through the point alpha comma beta. So we can write beta equals m alpha plus a by m, or m square alpha minus beta m plus a equals 0. Now we are given that these two tangents, they are perpendicular. If the tangents are perpendicular, then product of slope is minus 1. So here we'll get this condition that m1 into m2 is minus 1. Now m1 into m2 is nothing but product of slope, which is c upon a. So which is a upon alpha is equal to minus 1. That is alpha equals minus a. So locus of this point P is x equals minus a, which is nothing but directrix of this parabola, and it is a straight line, which is your option D. Now question number 11 is, we have to find local maxima and minima for this function. Now first we'll draw the graph of y equals x square minus 1. So it will be parabola opening upwards with vertex at 0, minus 1. This point is minus 1 and this point is plus 1. Now if we take the transformation of mod fx, we have to take the reflection of down on up, and then we have to erase the graph from third and fourth quadrant. So graph of y equals mod of x square minus 1 will be like this. This point is minus 1, this is 0, and this is plus 1. Now this function, it has local minima at minus 1 and plus 1, and at 0 it has a local maximum. So answer to this question is f has local minima at plus or minus 1 and a local maxima at 0, which is your option C. Now question number 13 is, let a be a fixed real number greater than minus 1. So a is greater than minus 1. We need to find locus of z satisfying mod of z minus iota a, it is equal to imz plus 1. Now we'll take z as x plus iota y. So it will be x plus iota y minus a, and it will be equal to y plus 1. Now modulus is x square plus y minus a whole square, and here will be y plus 1. So we square it, we'll get x square plus y square plus a square minus 2ay, and it will be y square plus 1 plus 2y. Now here y square will cancel. So we'll get x square as 2 1 plus ay, and then minus a square, which is nothing but a parabola. So the locus of z is a parabola, which is your option A. Now question number 14 is, which of the following is closest to the graph of tan of sin x? So we have y equals tan of sin x when x is greater than 0. Now we know that sin x, it lies between minus 1 and plus 1, and the interval minus 1 and plus 1, tan x is continuous and differentiable. So this function y equals tan of sin x, it will be continuous and differentiable in this interval. So this graph, it cannot be D because it is continuous and differentiable, and it cannot be C because C is not differentiable at pi by 2. Now it has to be between A and B. Now we look at tan of sin x. It has critical points at pi by 2 and 3 pi by 2. Now this is plus, minus, and then plus. So it has a point of local maxima at pi by 2 and local minima at 3 pi by 2. So its maximum value at pi by 2, it will be tan of sin pi by 2, which is 1, and it is tan 1. And its minimum value, it will be tan minus 1. Now we have to find whether tan 1, it is greater than 1 or less than 1. Now we know that 1 is greater than pi by 4. So tan 1 will be greater than tan pi by 4, and tan pi by 4 is 1. So its maximum value will be greater than 1, and its minimum value will be less than minus 1. So this B, it appears that this value is greater than 1. So the graph which is closest to the graph of tan of sin x is this option B. Now question number 15 is, we are given this function fx equals 2x upon x minus 1 defined from r minus 1 to r minus 2. We have to find whether this function is 1, 1, many 1, into or onto. Now for 1, 1, we'll take fx1 equals fx2. So it will be 2x1 upon x1 minus 1 will be equal to 2x2 upon x2 minus 1. We'll write 2x1 x2 minus 2x1 will be equal to 2x1 x2 minus 2x2. So we'll cancel. So the only condition that we'll get here is x1 is equal to x2. That means this function is a 1, 1 function. Now we'll find its range. We're given that y equals 2x upon x minus 1. We'll cross multiply. We'll write yx minus y, and it will be equal to 2x. X will be y upon y minus 2. Now since x is real, y minus 2 is unequal to 0. So range of this function is y is unequal to 2. That is, y belongs to r minus 2, which is equal to its codomain. When range and codomain, they are same, this function is an onto function. So this function is both 1, 1 and onto. And that's your option D. Now question number 16 is, consider real valued function f satisfying fx plus 1 equals fx for all x belongs to R. That means this function is periodic with period 1. We're given that gt is this integral from 0 to t fx dx, and we have defined this function ht as this limit n tends to infinite g t plus n upon n. Now if we look at gt plus n will be nothing but 0 to t plus n fx dx. Now we can write this as this integral from 0 to n fx dx plus n to n plus t fx dx. Now this function is periodic with period 1. So we can write this as n into this integral from 0 to 1 fx dx, and then plus, now this is from nt to nt plus a, and it will be from 0 to t fx dx. So we can write this function h as this limit n tends to infinite n, this integral from 0 to 1 fx dx plus this integral from 0 to t fx dx upon n. Now we split it in two parts. This n and n will cancel, and 1 upon infinite will be 0. So this ht will be nothing but will be this value from 0 to 1 fx dx, which is a constant function. So this ht, it is defined for all t belongs to R, and it is independent of t, and that's here option C. Now question number 17 is, consider the sequence a1 is 24 to the power 1 by 3, an plus 1 is an plus 24 to the power 1 by 3 for n greater than 1. Then we need to find integral part of a100. Now 24, it is greater than 8 but less than 27. So if we take cube root, then 24 to the power 1 by 3 will lie between 2 and 3. So basically this a1, it will lie between 2 and 3. Now we'll make an assertion that for any n, an will lie between 2 and 3, and we'll prove it using mathematical induction. Now if we take n as 1, we'll get a1 is greater than 2 but less than 3, which is true. That means the statement is true for n equals 1. Now we'll assume that let pk be true. Now if pk is true, we can write ak, it will lie between 2 and 3. Now if we add 24, we can write 26 is less than ak plus 24 and it will be less than 27. We can write 16 will be less than ak plus 24 and it will be less than 27. Now we take cube root, we can write 2 is less than ak plus 24 to the power 1 by 3 and will be less than 3. Now this is nothing but this is ak plus 1. So from here we can say ak plus 1, it will lie between 2 and 3. So from mathematical induction, we can say that for any n, this an, it will lie between 2 and 3, and then greatest integral function of any an will be simply 2. So we have to find integral part of a100 will be nothing but 2, and that's your option A. Now here the question is, let xy belongs to minus 2 to 2 and x into y is minus 1, then we need to find minimum value of this expression. Now suppose this is e, and we can write this as 4 into 9 minus y square plus 9 into 4 minus x square upon 4 minus x square into 9 minus y square. Now it will be 36 plus 36, 72 minus 4y square plus 9x square upon 36 minus, now it will be 4y square plus 9x square plus x square y square, which is nothing but 1. So we can write this expression E as 72 minus 4y square plus 9x square upon 37 minus 4y square plus 9x square. Now we can write this numerator as 37 minus 4y square plus 9x square plus 35 upon 37 minus 4y square plus 9x square. Now we divide it, we write E as 1 plus 35 upon 37 minus 4y square plus 9x square. Now we need to find minimum value of this expression. Value of this expression will be minimum when this denominator is maximum. And this denominator will be maximum when 4y square plus 9x square will be minimum. So we have to find minimum value of 4y square plus 9x square. So for minimum value, we'll use AM and GM. We'll write 4y square plus 9x square upon 2. It will be greater than or equal to under root of 36 into y square x square. Now x into y is minus 1, x square y square is plus 1. We can write 4y square plus 9x square will be greater than or equal to 12. So minimum value of 4y square plus 9x square is simply 12. So we'll write minimum value of E will be 1 plus 35 upon 37 minus 12. Now 37 minus 12 is 25. 35 upon 25 is 7 by 5. So it will be 1 plus 7 by 5, which is 12 by 5. And that's your option B. Now question number 19 is, we need to find this limit. Limit n tends to infinite 1 plus 1 upon n square plus n to the power n square plus root n. Now this is 1 to the power infinite form. And if it is 1 to the power infinite form, we'll directly use shortcut, which is e to the power limit n tends to infinite gx, which is n square plus root n into fx minus 1, which is 1 upon n square plus n. So it will be e to the power this limit n tends to infinite n square plus under root n upon n square plus n. Now since it is an infinite limit, we look at highest power of n. Now coefficient of highest power of n in the numerator is 1 and the denominator is also 1. So it will be nothing but e to the power 1, that is e, and that's your option A. Now the question is, we are given this function fx, which is x to the power 4 plus x square plus x minus 1 for x belongs to R. We need to find its zeros and its point of local minima or maxima. Now if we find f dash x will be 4x cube plus 2x plus 1, and if we find its second derivative, it will be 12x square plus 2, which is greater than 0. That means this function is concave up. So if the function is concave up, then its approximate graph will be like this. Now we need to find whether this graph, it will lie above x-axis, or it will touch x-axis, or it will intersect x-axis at 2 points. Now if we find value at 0 is minus 1. That means this function, it takes a negative value. So from here we can conclude that the graph of this function, it will intersect x-axis at 2 points. Now 0, it will lie somewhere between these 2 points, say alpha and beta. Now 0, it will lie somewhere between the two roots, say alpha and beta. Now we find f minus 1. F minus 1 will be 1 plus 1 minus 1 minus 1, it is 0. That means one of the root of this equation is minus 1. So that means this root alpha is simply minus 1. And what about other root? Now we look at first three options. It is 0 at minus 1, but increasing near minus 1. It is wrong because it is decreasing near minus 1. So option A is wrong. Has a 0 in minus infinite and minus 1. It has no 0 in this interval. Now third one, it has 2 zeros in minus 1 and 0. It is obviously incorrect. So option C is incorrect. That means this option D, it has to be a correct option. Now we have to show that this function has exactly one local minimum in minus 1, 0. So we have to prove that this point of local minima, which is say x1, it lies between -1 and 0. Now if we look at f dash x, then f dash minus 1, it will be -4 -2 plus 1, which is -5, and f dash 0 will be +1. Now since f dash x, this function, it is continuous, so there will be a point in between -1 and 0 at which f dash is 0, and suppose that point is x1. Now if we take this point as x1, before x1 this value is negative, and after x1 this value is positive. So sign of derivative changes from minus to plus. That means at x1 it is a point of local minima. So answer to this question is, this equation has exactly one local minimum in -1, 0, and that's your option D. Now question number 21 is, consider a sequence of 10 A's and 8 B's placed in a row. By a run we mean one or more letters of the same type placed side by side. Now here is an arrangement of 10 A's and 8 B's which contains 4 runs of A and 4 runs of B. So we have 1, 2, 3 and 4 runs of A, and then 1, 2, 3 and 4 runs of B. Now it says in how many ways we can arrange 10 A's and 8 B's in a row so that there are 4 runs of A and 4 runs of B. Now there can be two possibilities. Suppose we have runs of A's, then runs of B's, followed by A's and then B's, then A's, then B's, and then again A's and B's. In this way, we'll have 4 runs of A and 4 runs of B. Now suppose in this first run, number of A's is x1, in second run it is x2, third run it is x3, and fourth run it is x4, and for B, number of runs is y1, y2, y3 and y4. Now we have to arrange 10 A's. That means x1 plus x2 plus x3 plus x4 will be 10, and y1 plus y2 plus y3 plus y4, it is equal to 8. And we have to find number of positive integral solutions, because in each run there has to be at least one A or one B. So in the first case, number of positive integral solutions is n-1, so it will be 10-1c r-1. In the second one, it will be 8-1c 4-1. Now this is 9c3 and this is 7c3. So in this case, it will be 9c3 into 7c3. Now it will be the second case when the run starts with B. It continues as BA, BA, BA and BA. So again, we'll have the same case. So we just have to multiply this value by 2. So total number of ways in which we can arrange them in a row so that there are 4 runs of A and 4 runs of B is 2 into 9c3 into 7c3, and that's your option A. Now question number 22 is, for n greater than or equal to 2, fx is defined as x to the power n into mod x. We have to find the points where this function f is differentiable. Now we can write this function fx as minus x to the power n plus 1 when x is less than 0 and x to the power n plus 1 when x is greater than or equal to 0. Now f0 negative will be 0, f0 positive is 0, and f0 is 0. That means this function f is continuous in x belongs to R. Now if we find f dash x will be minus n plus 1 x to the power n when x is less than 0, and it will be n plus 1 x to the power n when x is greater than 0. Now f dash 0 negative it will be minus n plus 1, 0 to the power n. Now since n is greater than or equal to 2, this value will be 0. In the same way, we can find f dash 0 positive, so it will be 0 to the power n, which again is 0. So left hand derivative at 0 will be same as its right hand derivative. That means this function is differentiable everywhere, and that's your option C. Now question number 23 is this line 2x plus 3y equals k, where k is greater than 0, cuts the x-axis and y-axis at a and b. Now x-axis intercept is k by 2, and that's your a, and y-axis intercept is 0 comma k by 3. Now we have to find equation of circle with AB as diameter. So it will be x minus x1. So it will be x minus k by 2 into x plus y minus 0 into y minus k by 3, and it will be equal to 0. So this equation will be x square plus y square minus kx by 2 and minus ky by 3 equals 0. And that's your option C. Now question number 24 is, let alpha greater than 0 and consider the sequence xn equals alpha plus 1 to the power n plus alpha minus 1 to the power n upon 2 alpha to the power n. Then limit n tends to infinite xn is. So we have to find this limit n tends to infinite and xn is alpha plus 1 to the power n plus alpha minus 1 to the power n upon 2 alpha to the power n. Now what we'll do is, we'll consider this limit in two parts. We'll write limit, and if we take this first part, it will be 1 by 2 plus 1 by 2 alpha to the power n plus limit n tends to infinite 1 by 2 minus 1 by 2 alpha to the power n. Now we consider this first limit, which is limit n tends to infinite 1 by 2 plus 1 by 2 alpha to the power n. Now if we take alpha as 1, this value will be simply 1. If we take alpha greater than 1, in that case, this expression will be less than 1. Now a to the power infinite when a is less than 1 is nothing but 0. And if alpha is less than 1, in that case, this value will be greater than 1. Then a to the power infinite will be simply infinite. So this first limit will take the values 1, 0 and infinite depending on the value of alpha. Now for the second limit, which is limit n tends to infinite 1 by 2 minus 1 by 2 alpha to the power n. Now if we take this first case, when 1 by 2 minus 1 by 2 alpha, it lies between minus 1 and 0. Now this value will be minus 3 by 2, it will be less than minus 1 upon 2 alpha, and it will be less than minus 1 by 2. 3, it will be greater than 1 by alpha, and it will be greater than 1. And if we take reciprocal, we'll get alpha is greater than 1 by 3 but less than 1. In that case, this value, it will lie between minus 1 and 0. Then in that case, e to the power infinite will be simply 0. So for this case, value of this limit is simply 0. Now if we take alpha as 1 by 3, we'll get this value as minus 1. So it will be minus 1 to the power n. Then this limit, it will oscillate between minus 1 and plus 1. And if alpha is less than 1 by 3, then this expression, it will be less than minus 1. And if it's less than minus 1, then this limit, it will oscillate between minus infinite and plus infinite. Now, if we add these two limits, then this limit n tends to infinite xn, it will take this value 0 when alpha is greater than 1, it will be 1 when alpha equals 1, and it will be infinite when alpha is less than 1. So this limit xn will take the value 0, 1 or infinite depending on the values of alpha, and which is your option D. Now question number 25 is, in the first quadrant, which of the following is true? Now we know that in the first quadrant, sine theta is less than theta. That means option A is incorrect. Now we take cos both sides, and since cos is a decreasing function, sine will change. So we'll write cos of sine theta, it will be greater than cos theta. That means option B is also incorrect. Now if we take theta as cos theta, we can write sine of cos theta, it will be less than cos theta. That means option D is also incorrect. So this option C, it has to be the correct option. Now if we look at sine theta plus cos theta, now we know that sine theta plus cos theta, it is always less than or equal to root 2, and it will be less than pi by 2. So from here we can write cos theta will be less than pi by 2 minus sine theta. Now if we take sine both sides, we can write sine of cos theta, it will be less than sine of pi by 2 minus sine theta. That is sine of cos theta, it will be less than cos of sine theta, which is your option C. Now question 26 is, consider a cardboard box in the shape of prism as shown below. The length of the prism is 5 units. The two triangular faces ABC and A', B', C' are congruent and isosceles with sides 2, 2 and 3. The shortest distance between B and A' is. So we have to find shortest distance between B and A'. Now if we look at this face AB, B', A', it is nothing but a rectangle. So we have A, B, B' and A', where A' is 5 units and AB is simply 2 units. Now the shortest distance between B and A' is distance along diagonal, and this distance, it is nothing but it is 4 plus 25, and it will be under root 29, and that's your option A. Question number 27 is, assume the following inequalities for positive integer k, and the inequality is, we'll multiply everything with 2. We'll write 1 upon under root of k plus 1 will be less than 2 times under root of k plus 1 minus under root k, and it will be less than 1 upon under root k. We have to find integral part of this summation. 1 upon root 2 plus 1 upon root 3 up to 1 upon under root 9999, and let this sum be S. Now we put k as 1, we'll write 1 upon root 2 will be less than 2 into root 2 minus 1, and it will be less than 1 upon root 1. Now if we put k as 2, we'll get 1 upon root 3 will be less than 2 into root 3 minus root 2, and it will be less than 1 by root 2. Now if we put k as 3, we'll get under root 4 will be less than root 4 minus root 3, and here will be root 3. Now we continue like this till k equals 9999. We can write 1 upon under root of 1 0 0 0 0 will be less than 2 into under root of 1 0 0 0 0 minus under root of 9999 and it'll be less than 1 upon under root of 9999. Now we'll add them all up. Now if we add them all up, here we'll get 1 upon root 2 plus 1 upon root 3 up to 1 upon root 9999 plus 1 by 100 and it'll be less than. Now here when we'll add them, all these terms they'll cancel. We'll get 2 into this value which is 100 minus 1 and it'll be less than this sum which is 1 upon root 1 plus 1 upon root 2 up to 1 upon root 9999. Now 1 upon root 2 up to 1 upon root 9999 is nothing but s. So we can write s plus 100, it is less than 99 into 2. 99 into 2 is 198 and it'll be less than 1 plus s. Now from here we can write s is less than 198 minus 1 by 100 and s is greater than 197. So value of s, it lies between 197 and 198 minus 1 by 100. That means integral part of s will be nothing but 197 and that's your option B. Now question number 28 is, we are given two sets. Set A is x to the power 4 plus y square is less than equal to 1 and set B is x to the power 6 plus y to the power 4 is less than or equal to 1. So for this set A, we are given that x to the power 4 plus y square is less than equal to 1 and for the set B, we are given x to the power 6 plus y to the power 4 is less than or equal to 1. Now since both the powers, they are even powers and this expression is less than equal to 1, that means x to the power 4 is less than equal to 1 and y square is also less than equal to 1. In the same way, x to the power 6 is also less than equal to 1 and y to the power 4 is also less than or equal to 1. Now we know that when x lies between 0 and 1, x to the power 4, it will be greater than or equal to x to the power 6 and in the same way, y square will be greater than or equal to y to the power 4. So if we'll add them, we can write x to the power 6 plus y to the power 4 will be less than or equal to x to the power 4 plus y square and will be less than or equal to 1, which clearly shows that if x square plus y square is less than equal to 1, then x to the power 6 plus y to the power 4 is also less than or equal to 1. So all the solutions of this inequality, they automatically satisfy this second inequality. So all the points in set A, they are contained in this set B. So answer to this question will be A is a subset of B and that's your option B. Now question number 29 is, this number 2 to the power 10 upon 11 to the power 11 is which of the following option? Now we are given that 2 to the power 10 upon 11 to the power 11. Now we look at 2 to the power 10, we can write this as 10C0 plus 10C1 up to 10C10. Now what we'll do is, we'll take arithmetic mean and geometric mean of these 11 numbers. So its arithmetic mean will be this value divided by 11 and it will be greater than their geometric mean and their geometric mean will be 10C0, 10C1, 10C2 up to 10C10 whole to the power 1 by 11. Now we'll take power of 11, then we can write 2 to the power 10 upon 11 to the power 11 will be greater than 10C0 will be 1 and 10C10 it is 1. Now 10C1 and 10C9 they'll be same, so it will be 10C1 square. Now 10C2, 10C8 they're same, 10C3, 10C7, 10C4, 10C6, and then we have 10C5. So this 2 to the power 10 upon 11 to the power 11 is strictly greater than 10C1 square, 10C2 square, 10C3 square, 10C4 square into 10C5, which is your option A. Now question number 30 is, if the roots of the equation x to the power 4 plus ax cube plus bx square plus cx plus d equals 0 are in GP, then which of the following option is correct? Now let the roots be alpha, alpha r square and alpha r cube. Now we can find sum of roots. Sum of roots will be alpha 1 plus r square plus r cube, and it'll be equal to minus a. So from here we write a as minus alpha into 1 plus r into 1 plus r square, and that's our first equation. Now we'll find S2. Now S2 is sum of roots taken 2 at a time. So 4C2 and 4C2 is 6. So we'll have 6 results. So S2 will be alpha square and then r plus r square plus r cube plus r cube plus r to the power 4 plus r to the power 5, and this value will be equal to b. Now here we'll take r common and here we'll take r cube common, so we'll get alpha square and it'll be r 1 plus r square plus r cube 1 plus r square, and it'll be equal to b. So we'll get alpha square r 1 plus r square 1 plus r square, and it'll be equal to this b, which is our second equation. Now S3 is taken 3 at a time, so it'll be alpha cube. Now the product is 3 into 5 and 6, so it'll be r to the power 6 plus r to the power 5 plus r to the power 4 plus r cube, and this value will be equal to minus c. So we'll get alpha cube and here it will be r cube 1 plus r square plus r cube equals minus c, which is alpha cube r cube 1 plus r into 1 plus r square, and this value is minus c. And finally we'll write S4. S4 is product of all the roots, which is alpha to the power 4 and r to the power 6, which is nothing but d. Now what we'll do is we'll find a square into d. A square into d will be alpha square 1 plus r square 1 plus r square whole square into alpha to the power 4 r to the power 6, and we can write this as alpha cube r cube 1 plus r 1 plus r square whole square, and this is nothing but this is minus c, so it will be c square. So the result that we'll get from here is a square d equals c square, which is your option D.